Right, so we kind of left off with doing, starting with these normal distributions in our calculator. So hopefully we're all looking at the same place here. Okay. All right, and we had done kind of these ones. Do you remember how we put these in the calculator? So if I drew this picture, right? When we have z-scores, we kind of have this picture. And so if I want to find the probability I get a z-score in between -1 and 1, we already know that's essentially one standard deviation on each side of the mean. So we should get that about 68% of the time, right? And just so to teach Mr. Belt, because he's never used a calculator to do this before, I'll show you what we used in just a second. Okay, if you hit second vars to bring up that distribution menu, right? Is this familiar? You guys, which one do I want to pick for this? Normal CDF. Yeah, so we're going to pick normal CDF. And my lower bound in this case would be, well, those are the boundaries of my shading. So the lower bound of my shading is -1. The upper bound of my shading is +1. And what are we expecting to get as our answer here? 68%. And hey, that worked out just fine. Okay. So we did these kind of ones that we already knew what to expect. Next, we're going to look at a few more kind of just examples of ways I might ask you questions about these. So I might ask you, well, what if it's not a whole number of standard deviations from the mean? So if I'm finding the probability that z is less than -1.45. Okay. I don't know why I put my standard deviations on you guys. Okay. All right, so -1.45 is approximately 1.5 standard deviations below the mean, give or take, right? Okay, and I'm finding the percent below that. All right, so if I'm looking at this in that menu, and I go to my normal CDF, which you guys, let me go back to the video so you can see what I'm typing here. What do I put in for my lower bound in that case? Because it's going down kind of forever and ever and ever, yeah? Is everybody okay? All right. So I want you guys to envision as I get way, way, way over here, which is technically where I'm shading, right? I'm shading all the way to the left forever and ever and ever. You guys, what's going to be the area over on this edge? Are we cool with calling the area over on this edge practically nothing? Okay. So what we do is technically, my lower boundary here is -infinity, technically. But you can't type in -infinity in your calculator. So it's so close to 0, what you do is call it -a gajillion. So I just do like some really, 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 really low number. Okay. Because it's so far away, anything that far to the left, everything that small. So -infinity is -a gajillion. Okay? In this particular world. Not in real life, but okay. And what would my upper boundary be? -1.45. So this probability is 0.0734. Does that feel okay? Now, you guys want to feel crazy? Let me show you how Belk and I used to do this when we learned statistics. Did you have a TI-82?
I did.
Okay.
Well, I taught on 84.
You taught on an 84?
Yeah.
You didn't teach statistics. So when you learned statistics, you were on an 82?
Oh, learning, yeah, 82.
Yeah, I was on an 82 myself. Yeah, that 83 is when they started having
The stuff.
the stats packages. Yeah, so I'm going to show you guys something real quick. This is how we used to find these probabilities. We had a table like this. And on that table, so we just did negative 1.45. So we would go to, let's see, negative 1.45 would be, here's the negative 1.4, there's the 5, so negative 0.0735. That's how we had to find it. And on every stats test, we were given tables. This is only half of them. Here's the other side. And then usually by the end, we had other tables. We'll learn how to use these in Unit 7. So your calculators are pre-programmed with those tables, hence we use the calculators. But that's how we had to used to have to do these. Okay, so let's go ahead. All right, real quick. What would this picture look like? And as I draw this in, okay, which direction am I shading in this case? It's backwards for me. Okay, so greater than would be this way, okay? And so what's my lower boundary? Negative 0.2, and my upper boundary is going to be positive a gajillion. Okay, now before you put this in, before you put it in, let's predict, what do you guys expect this answer to be? Because we're going to start getting lots of decimal answers, right? These are probabilities we're getting probably every time. It helps us sometimes to kind of think through what's a reasonable answer. As you look at this, if you got 0.99 based off of our picture, would that feel icky? Because that's way, right? Negative 0.2 is barely below the mean, right? Okay? So this should be, I don't know, a little bit more than half. Right, so I want us to maybe start thinking about what is a reasonable answer, because that's going to start helping us think through if we're in the right place or not, if we're doing these correctly or not. Okay, now put them in. What are you guys getting? Negative 0.579? For your upper, was this positive or negative? Or did you do them backwards? You should have gotten a positive 0.579. But what happens if you did your lower and your upper backwards, because the way it does this is it kind of takes the right hand, like the right hand boundaries area to the left minus the left hand boundaries area to the left. So they subtracted it. Are we good? All right, and then lastly, this one down here. Did you guys get 0.869? How are we feeling about the normal distribution so far? Great. I'm going to change it a little bit. duh, right? Once we're feeling good with one part, we're ready to build on to another part. Which was crazy. All right. Whew. What is the z-score of the 35th percentile? Oh, man. Does anybody remind me, what does 35th percentile really mean? What does it mean for something to be the 35th percentile? My height is roughly the 15th percentile for women my age. What does that mean? Am I really tall, guys? Really short? Short. 15% of women my age are shorter than me. Okay, so that's always your percent lower. So that means there's some z-score. We don't know the boundary, okay? So I'm just going to mark it with a z right now, okay? And 35th percentile would mean that the area is 0.35. Okay, so this is essentially, instead of having the boundary and finding the area, finding that percentage, what we have is the percentage, and we're trying to find the boundary. Okay, so we're still using that normal distribution, that known probability distribution. So we hit second distribution, bring up that, or second vars, bring up that thing, bring up that menu. And now as you stare really hard, do you see anything that might help us work backwards within the normal distribution? Inverse. You guys see where it says inverse norm? Choose inverse norm. And the lovely thing is when you choose inverse norm, what does the calculator ask you for? It asks you for an area. Are you guys with me? So here's the deal. It's really easy to pick the wrong thing. Okay? If it's asking you for something you don't have, cancel out and go into the one you do have. Okay? All right. So I know the area is 0.35. For everybody, for both of you guys, live in Nadia. Yours looks a little bit different. Where, you're just remember for you guys, your calculator always does left-hand area. So in this picture, the 35% is the area that's on the left-hand side. These ones, they give you a choice, which side you want to do. Those ones are an older operating system. Yeah, so when it asks for the area, okay, so when it asks for the area, you're always going to give it to the area to the left of what you're trying to find. Okay? All right, so you guys, now, what should we expect on our z-score here? Positive or negative? Negative, because it is to the left of 0, yes? Okay, so if you don't have left highlighted, the area we have is a left-hand area, so make sure you do that one and hit enter. And you guys, I got that z-score to be negative 0.385. Okay. So it turns out, okay, so if I say what z-score correlates with the upper 5%, are you with me that would mean my right-hand tail is 0.05? That's what I would know if I was in the upper 5%. So what do I have here? I have an area, okay? All right, so what z-score goes with that area? If I have the area, that tells me I'm doing inverse norm, but those of you with these kinds of calculators where you can choose left, center, right, you can put 0.05 and highlight right. You guys, if this area is 5%, what does that make this area? So you guys have to put in the 0.95. And I'm not very good, but I bet this one's 1.645.
Like, how do you know that? You just remember that?
That's a value that comes up a lot. It'll make sense when we get to Unit 7. But that particular one, like the boundaries for the 5%
Oh, yeah.
and boundaries for the 2.5% come up really, really frequently in what we do next. So that's why I know that. It's not because of intelligence. It's because it's just lots and lots of experience. Okay, so again, I want to make sure we all understand kind of what's going on. So I'm going to try to put this number into perspective. That loud guy next door is in the top 5% in age of people in this building, yes? So we could say his age is 1.645 standard deviations above the mean. Is that super old?
No.
No. But I would put him in, I would bet he's in the top 5%. Maybe the top 10. Okay. All right. Lastly, the last thing we might need to do with these is find the middle 85%. Or a middle percentage, okay? All right. And if that's the case, if I have 85% in the middle, those of you that can, you can choose center, right? Now, first of all, how many z-scores are these boundaries? Well, I got one here, and I got one here. So I'm actually expecting 2 different z-scores, okay? All right, now, total, these 2 regions have to equal everything but the 85%, right? So are you with me that these 2 regions have to equal 15% combined, which makes each of them 7.5%. So you're going to kind of have to cut that in half to kind of get there. That's a good idea for all of us to know, though, for later, that if we're finding the center, like you do 1 minus this and then cut that in half to get each of the tails. And hopefully you got 2 answers, 1.43 or 1.440 and positive and negative 1.440. And in this case, we have 2, again, because we have the one above the mean and the one below the mean to be able to be the center. Yeah. Did you get negative? Or wait, did you put in the left hand? No, that's 1.44. That's negative 1.44. So what you found this one. Liv. And if this one's negative 1.44, you can use the fact that this is a symmetric graph to know that the other one's positive. If at any point, like for this stuff, if you want to use one of mine where it has the left and the center and the right, that's fine. Okay. All right, so far we've been focusing on what we call this standard normal. That is z-scores. But in the real world, distributions are not are not standard normal. They have their own means. They have their own standard deviations. So we're going to talk about some cows. Cows have a mean weight of 600.
Any seniors with the last name starting R through Z, please come down to the front hallway to get your cap and gown pictures taken. All seniors with the last name R through Z. Thank you.
And a standard deviation of 45. So here's what we know now. The mean of our population is 600, and the standard deviation of our population is 45. Okay? That's essentially what that means. All right. So if I want to know which weights would be considered unusual, what was our metric for unusual? 2 standard deviations from the mean. Okay, so to figure out what is unusually small, I'm going to do 600 minus 2 standard deviations. To find unusually big, I'm going to do 600 plus 2 standard deviations. Hopefully we're getting 510 and 690. Okay, great. So if a cow weighs 500 pounds, is it unusual? Unusually small. What about 511 pounds? Is that unusual? No. We all good? All right. So now we're going to go to a field. We're going to go randomly pick a cow, and I want to know what is the probability that cow weighs less than 675 pounds. So let's draw that picture real quick. The first thing we do when we draw that picture is we're saying it's normal, so we can draw that bell curve. And I want you to label the mean and the standard deviation. Okay? And then you say, well, where is 675? It'd be probably right about here. Like 675 is more than 1, less than 2 standard deviations below the mean. So that's kind of how I'm judging where to put it. Okay? And so essentially, we're looking at this section of our graph. And we're trying to find the probability that a randomly selected cow weighs less than 675. Are we good? And the basic premise of the question. All right, so from here, on our calculators, you're still going to go into that normal distribution menu because the picture looks a lot alike, a lot the same. And our boundaries in this case, well, it's shading all the way to the left. So how do we do all the way to the left? We do negative a gajillion. What is my upper boundary of being shaded?
675.
The 675. Okay. You guys, this symbol on your calculator, like you see it almost looks like a U, right? It is attempting to look like, it's the calculator attempting to ask for this Greek mu symbol, okay? So that second, that weird symbol, that is your mean. So this is where we put the 600. For the what do you think I'm going to put for that last symbol that looks an awful lot like that Greek sigma for a standard deviation? We put the 45. So what do I need to see in order to see like what you put in your calculator? I need to see this picture with the mean labeled, the standard deviation labeled, the boundary, and the shading, okay? If you get to this and get the wrong answer, you're going to get 4 out of the 5 points because you're showing me you know what you're doing, okay? But if you just give me a wrong answer, then I don't know what you did to get there. I don't know what your thinking is. So 0.952. Pretty likely that if we just randomly go to a cow pasture and pick out a cow, it's pretty likely it weighs less than 675 pounds. Similarly, if I want to find the 40th percentile in weight, we're still going to label that mean. We're still going to label that standard deviation. And you guys, tell me where to stop my cursor in terms of where do you think the 40th percentile is? A little bit below the mean, yeah? Because the mean would be what percentile? 50. Great. So, all right, so now I'm looking for the boundary So what am I gonna pick in my calculator? I'm gonna pick the other one, the inverse norm. But I can still fill in that mean and standard deviation in the exact same way. So 588.6 pounds. A little bit below the mean. Everybody feeling okay? All right, let's turn the page. So, are you guys hopefully starting to see that the what is unusual is an important kind of concept that we want to be thinking through? Okay, we'll do our 52 plus or minus 2 standard deviations. Let's see, for the smaller than, we should have gotten 43.4. Thank you. And then bigger than 60.6. Okay. So you guys, true statement, Duncan Peters was taller than me when he was in 2nd grade. True.
Are you serious? Oh my goodness.
2nd grade.
2nd grade?
That's unusual. Yeah. Because 60.6 is just a little bit shorter than me, right? So, you guys, I'm tall for a 10-year-old. Just saying. All right. Why don't you try this next one? So before I touch my calculator, I get these labeled because it's a lot. I don't like to touch my calculator until I've drawn the graph, because it helps me visualize what I'm putting into that calculator. Then I go to my calculator. Did I get it right? You should check my calculator skills. All right. How tall is Q3? Man, Q3. What do we remember? Q3 Where is Q3 relative to the mean? Bigger than or smaller than? Bigger than. Okay. And what do I know about the area to the left of Q3? What would that be? Well, let's see. To find those quartiles, the first thing we did was find the median, and we had 50% below the median, right? And then Q3, we found the median of that upper half, right? So it is 75%, because it's half of that upper half. Okay, so Q3 is equivalent to the 75th percentile. All right, I want you guys to try these 2 problems on the bottom, check your answers, and when you're done, you have the rest of the class to either finish up the Excel lab if you haven't done / turned it in, or check out the homework, or keep working through the homework. When is all of that due? Midnight tonight. Homework and lab due by midnight tonight. If you want to check your answers. You can talk about your question now.